Hello, hello, testing. How's everybody doing tonight? Yeah, you could test record. I'm recording also, hopefully much better. I think I fixed everything, but uh, I got a few things to warm up with before I let Ben take the stage because he has everything prepared tonight. I don't need to do much. So, I'm going to post in the chat for whoever wasn't here last week. This was kind of the assignment for if you're just starting the practical ethical hacking course. This is what you should have completed at the minimum. Um, okay, good. We'll have a backup if mine fails again. Hopefully not. Um, the so we did note keeping last week with Jacob. Awesome. Um, we're going to recap the network portion of this lesson plan from last week. Ben has something prepared for that, and then I'm going to post the stuff for next week. So this, what I just posted in the chat, is what everyone after this session today should start working on. But the stuff Ben is going to cover also relates to this. Before, so Ben, you're going to start with networking, right?
Yep, that's the
Okay.
plan.
Does anybody have questions? Ben's probably going to cover your questions in his presentation, but is there anything, if you want to post in chat now, um, any network stuff that you had trouble with while you were going through this, or just any network questions in general? There was a video last week. I messed up the audio terribly. It's on my YouTube. Um, I'll post my YouTube in the chat while after Ben starts. But any questions on or stuff that you would like to see covered on networking before we get started? CIDR notation. I'm trying to find my own YouTube channel right now. All right, so that's my YouTube channel. It's in the beginning stages. I'm learning with recording. I switched from, I forget what I was using, like Bandicam. I switched to OBS. OBS seems to be much better, so my videos should be getting better as time goes on, and my editing skills get a little bit better. But I did not do that. 7 second subnetting. That is, yeah, 7 second subnetting helped me pass my Network Plus. That's a good video. I think Heath might even link to that in the course. No, maybe. Well, seems like most of this is scripting. So yeah, sure. Yeah, but Ben has a great presentation um, to go over it even better than I think the course does. So you ready to take it away,
Yeah,
sir?
also going to be relevant. Also going to be relative to your overall experience with scripting and programming in general. So
I got a sneak peek at the course, or what he has prepared, not the course. I'm sorry, what he has prepared, and it's good. So I'll let you take it away.
cool. All right, let me go and share my screen here with everybody. Make sure you all can see that. Everybody good? Can you see the screen share? Yeah, I see
Yep, I
one.
got
Yep.
you.
Cool. Hey, what's up? All right, cool. So for today's lesson, I'm going to be covering a lot of ground. So I'm going to try to We're not going to be going into a great amount of detail among the stuff we have here because it's pretty lengthy, but we can try to address questions at the end if we have time for it. So go ahead and dig right in. So we're going to talk briefly about IP addressing, but before we do that, it's important to know some of the most common computer numbering systems that you'll see operating systems and network interfaces working with. So among them being binary, also known as base 2, octal base 8, decimal base 10, and hexadecimal base 16. You can see that binaries runs sequentially from 0 to 1, 0 to 7 for octal, 0 to 9 for decimal, and 0F for hexadecimal. And pardon me for clearing my throat. I was recently sick, so still trying to get through all that. Bear with me. So we'll start with base 10 since that's the one we're all familiar with. So when you see the number 4529, you're going to instinctively think 4,529. Assuming that you speak English. From birth, we as humans are taught to count in base 10. 10 is a nice even number. Working in multiple 10 is easy. So if we look at this number here, we know that this is the ones position. So 1 through 9, 0 through 9. This is your tens position. This is your 100s position, and your thousands position, and so on and so forth. Multiples of 10, so that the math equals out that if you do, so if this is a 9, 9 times 1 is 9, 2 times 10 is 20, 5 times 100 is 500, and 4 times 1,000 is 4,000. You tally down 9, 2, 5, 4, you get 4,529. It's base 10 calculation. Base 2 works similarly. So where you have the ones, and then you go 10, and then you multiply again by 10, you get 100, multiply by 10 again, you get 1,000. With 2, you start with the ones position, then you go 2, then you go 4, then 8. Those are the positions, so to speak, of these numbers here. So that when you see a binary number, such as 1010, it's the same process again, this being the ones position, 0 times 1 is 0, 1 is activated, times 2 is 2, 0 times 0 is 0, and 1 times 8 is 8. So you tally that down and you get 10. That you're converting binary base 2 to base 10. You get the number 10 in hex as 0A. Similar story with hexadecimal. We'll skip the procedure just for the sake of time, but you can always refer back to this cheat sheet here after the presentation today. But it works in a similar fashion when you encounter a base 16 number. So you just F is 15 and you just multiply. So you can come back to that. We'll, again, looking at some more decimal to binary examples and binary to decimal. If you have so we know that a byte is 8 bits. So that's hence we have 1, 2, 3, 4, 5, 6, 7, 8 bits possible. And with binary, you either have a 0 bit or a 1 bit. That's what you're working with in binary. So in this particular byte, it's all of your bits are turned off to 0. So this bit of binary here, 0, 0, 0, 0, 0, 0, 0, 0 equals 0 in base 10. Whereas if you have all ones, you're summing up to 255, again, because 1 times 1 is 1, 1 times 2 is 2, 1 times 4 is 4, and so on and so forth. After doing the multiplication tables, taking all of these values and summing them up, you get 255. Now, for a long time, I'll admit, in my more junior years, I would you'd often see this mixture of referencing 256 and 255. Why is 1 255 when we know 2 to the power of 8 is 256? Well, that's because here we're not including the potential for this bit to also be a 0. So if we're calculating all the possible permutations of on and off bits in an actual 8-bit byte, there's 256 possibilities. And that's why you'll, mathematically speaking, 8 bits, there's 256 permutations, whereas when we're just doing that binary to decimal calculation, we're just taking these, we're multiplying by 1 these sequential values and then adding them up with the sum equaling 255. So just clearing it up, that 256 is possible because this can also be a 0. This bit here could be off. So more examples as well. Just taking 1100000000. You multiply all the values up. Your sum is 192 in base 10. I'm pretty sure I copied and pasted wrong here, so I'll correct that in the notes later. But if we tally all that up, it's not 192. That's bad copy and paste on my part. So I'll correct it later. But moving on for the sake of time. So now with IP addressing, I'm going to read off my note here because it's pretty important that you'll see a lot of people will, there's a lot of purists out there in terms of computer networking and IP in general, where if you're still using IPv4, you get ridiculed and it's like, oh, you haven't converted to IPv6 yet. And it's really just not that important because in general, when we're dealing with our internal networks, our private, non-internet routable networks, if you choose to use IPv4 in your internal addressing, it's just not a big deal. I mean, congratulations to you if you do convert to IPv6, but the whole notion of converting from IPv4 to IPv6 is this notion of exhausting all internet routable IP addresses. And that is important, but that's not going to happen in your internal network. You're not going to exhaust all possible IPv4 available addresses in your private network. So that's the key takeaway here, that if you choose to IPv4, if you choose to use IPv4 privately for your non-internet routable addresses, it's perfectly acceptable. And just tell anybody who decides to comment about it to just take a hike because it doesn't matter. So noting here that we can take, with IP addressing, you can actually document your, we are most comfortable and acquainted with the dotted decimal notation. So we take the decimal values and separate them by periods. So we have quadrants. We have like 192.168.1.0 would be a dotted decimal address, but you can actually take any IP address, convert it to its base 2, base 8, base 10, base 16 value, and your network interface card is going to understand what IP address you're referencing here. And I'll show you. I will take a look at this really brief example here on this fantastic site here, hacksparrow.com. This particular person is demonstrating here that you can represent your IP address in full binary, in octal, in hex. And if you ping, for example, this particular address here, which we've got, a whole bunch of binary here with 177.0001. Obviously, I'm not sure which address format we're coming from there, but I want to say it's probably octal. That this network interface card is able to understand a mixture of those notations. So even though we are most comfortable seeing an address such as this, 127.0.0.1, your network interface card can work seamlessly with a range of base, whether you choose to do binary, octal, decimal, or hexadecimal. IP addresses can be represented in a wide variety of formats. That's the key takeaway here. So even though you're used to seeing those dotted decimals, you should also get used to seeing IP addresses in decimal format, because I've worked with a handful of security tools in the past that the IP address is exclusively stored in decimal. It's probably an example that if I go back to this web page here, probably give you an example. If not, right here, this would be a decimal. This is 127.0.0.1 in decimal. Base 10 is this. So you might encounter a security tool where they're like, oh, the IP address, source destination IP address is this, and you're looking at it, it's like that's not an IP address. It is an IP address. It's just this is a base 10 notation of the IP address. So you should get used to seeing IP addresses in multiple formats. Um, move on for network masking. So an IP address alone is meaningless without a network mask. If you have an IP address exclusively, you might be able to infer which network this IP address belongs to, but to truly understand, you get an IP address, you need the network mask to really determine what the network address space is of that IP address. So just saying that you need both parts. You need both IP and the subnet masks to really be able to say 100% surely which network address your IP address belongs to. Um, you can think of a subnet mask as like a zip code, whereas a postal code confines residences to a specific area. A network mask confines hosts to a specific route. We also use masks to determine the size of the network, and the subnet mask is also, in its simplest form, just a series of binary, where your subnet mask will either be all ones, partial ones, or all zeros. We'll cover more of that later, but just know that the subnet, just as the IP address can be represented in binary or octal, so can your subnet mask be represented in binary, octal, hex, etc., etc. Um, and there's no more classical networking. I don't like dwelling too much on the idea of class ABC networks. Those days are long gone. The world is now operates on classless interdomain routing, CIDR. Instead, you should think of networks in terms of whether it's internet routable or non-internet routable. That's how you should be thinking about IP addresses. Um, you have your public WAN, internet routable IP addresses. You have your private non-internet routable IP addresses, diagnostic, experimental, reserved. Point being that you should look at there are certain RFC specs that define what those internet, basically there are you have your reference up here, your diagnostic, experimental, reserve. Those are all in your RFC specs, so you can go Google those later if you'd like. But RFC 1918 will discuss exclusively your IPv4 non-internet routable addresses, and RFC 4193 is a non-internet routable IPv6 address space. There are other RFC specs, like I said, that you can go Google to learn more about these diagnostic, experimental address spaces. But we'll leave it there for now. Just know that classical networking is gone. We don't talk about that anymore. Um, tonight, talking about subnet masks, we're going to stick with IPv4. Again, I'm not an IPv6 guy. Just not. So if you came here looking for IPv6 knowledge, sorry to disappoint. But so we're going to talk about. I think someone was wanting to work on the CIDR blocks. So we're going to touch on those here briefly because we do have a lot to cover. Just know that the /8, 12, 16, as noted in our RFC 1918, those are called CIDR notation or CIDR blocks. The number appearing after the slash directly correlates to the number of 1 bits in the binary notation of the subnet mask. So to demonstrate, basically any octets where the value is not 0 is considered the network segment. And any octets where the value is 0 is considered the host segment. So we'll look at this. We'll look at this further here. If we look at the /8 notation, that means 8 bits are on in the subnet mask. So if we look here, we have 111, 111, 111. Probably said that a little more than 8 times, but still, if you look at the arrows here, anything where all of the 1 bits are activated, want to demonstrate this indicates the network portion of the address. So in other words, this 10 will never change. This is the network ID. But any IP, any portion of the IP that's masked by zeros is all variable. And so this here can be 0 through 255, 0 through 255, 0 through 255. This will never change. This is your network ID. It's not going to change because it's masked by all ones. Likewise, over here, if you look at the RFC 1918 spec, we know that 172.16.0.0/12 is a reserved private IP address space. If we look, why is it 12? Because if you convert 255.240 to decimal, with 255 being all ones and 240 being 4 ones activated in the network mask, 8 plus 4 is 12. Hence, we have a /12 notation. Likewise, for /16, we have 8 ones, 8 ones, 8 plus 8 is 16. So hopefully you're starting to piece together where we get that CIDR notation from. The slash value is a calculation of the number of 1 bits in the subnet mask. We're not at subnetting yet, so we're not going to explore this, why there are ones and like a partial 1 and partial zeros. We'll get there in a minute. But just since we're talking about CIDR and subnet masks, again, reiterating that the slash notation indicates the number of ones in the subnet mask. It's a sum of those. Now, it's important to know these subnet masks because every network interface card, your laptop, your Raspberry Pi, your smartphone, anything with a network card is going to need to know its network mask so that it can populate its routing table. So your smartphone, your laptop, your desktop, your game console, those are all hosts on your local area network. They need to be able to infer who is in my local network and who is in a foreign network. And the only way they can make that determination is by knowing what their own private local area network is, what their own local area network is. So when they go to send a packet, can I put this packet on the wire and address it to somebody on my network, or do I need to send this packet to the default gateway so that the default gateway can send the packet somewhere else? Those are the distinctions the network card needs to make. So when we're talking about subnetting, I know I say here don't overthink it, but really I want you to not overthink it because I know I did for a long time. And the only way you can really, I think, get over the fear, maybe not even fear, but also the challenge and the mental block that is subnetting, is you just have to do labs. without doing subnetting, it's just the why of it doesn't make sense. If so, that's the only, if you're not doing subnetting labs, you haven't set up a virtual network and done subnetting, it's just often hard to make sense of the why. I would love to. I would love to do some subnetting with you, but unfortunately, I've got a ton of material to get through. So I'm gonna have to respectfully uh, keep that till probably have you keep practicing that after the lesson today. I'm happy to field questions with you once the lesson's done. Yeah, free time, I can definitely field some questions for you. So, um, so if So why do we subnet? We subnet for predominantly two reasons. On no IP tables, man. No. Come on now. Oh, you're trying to torture me here, man. Come on. Like, oh, IP tables. That's good. It's a good one, man. You want everybody to leave the meeting, don't you? No net show either, man. No net show. I mean, that's good stuff. Like firewalls and all that. Yeah, it's good, but no, we're not doing firewalls today. Uh, /16 network will yield again. So why do we subnet? We have predominantly two reasons to subnet. We're looking to either A, shrink the size of a network, or B, take multiple networks, make multiple networks from a single network block. So I'm going to give two examples here. Scenario A, you have by default in RFC 1918 this reserved address space of 192.168.0.0/16. That's going to yield you 65,534 possible usable IP addresses for hosts. You can't do that at home. I surprise me if you will, but I don't think we're going to find anybody who has 65,534 unique hosts in their home to address. So what you'll often see do is when people send are you talking about VNets or VLANs? I'll come back to that in just a second. But uh when you see, yeah, those are different. We'll talk about those too. I actually have a little segment on that in a minute. But when we're talking about, let's say you sign up for your whatever the Verizon or Cox or Comcast or whoever your internet service provider is, you call them and say, hey, I need internet service. Generally, they're going to send you a router and a modem, depending on your internet service, and they're going to say plug it in and we'll set you up. And generally speaking, when you plug that in, you have something like a 192.168.1.0/24 or a 192.168.0.0/24. And the reason for that being is because the the people who manufactured your router, they send it to you with a /24 because it's a pretty reasonable network size. All they've done is just taken all of these zeros and changed them all to ones, and so now you've got 192.168. You can choose a number between 0 through 255 here. Any number, it doesn't matter. And now all three of these never change. They're static. That's your network ID. They don't change at all, period, because they're all ones. All right. This is your network ID. And 0, all masked by zeros. This can be any number between 1 and 254 as a usable address. So all the manufacturer did is just flip these to ones in order to, again, shrink. Why do we subnet? We're just shrinking the size of the network. It's too big. We don't need all those IP addresses. So we just shrink it. Scenario B, we increase the number of networks. We're thinking about this from a business perspective. You are working at an office branch and you are a network administrator. The network engineer at HQ gives you a 10.10.00.16 address space to work with. You don't have a choice. That's the network engineer. This is what you're given. On its own, this address space is going to yield one. You have one network, period. This is the one you've been given, and 4,906 possible addresses for your host. But the problem here is you're setting up a new office and you only have one possible network, but you need three for sales, HR, and engineering. So you need to break it up by subnetting it. So here's our current subnet mask: all ones, all zeros, /16. But you need three networks. So we need to calculate the number of hosts. See, these are marked host right here. These are host bits. We need to borrow host bits. And how many host bits do we need to borrow? We figure that out by a equation known as 2 to the power of n. So 2 to the power of 1 is 2, not enough. 2 to the power of 2 is 4. That's more than we need, but that's our only choice. So we need to borrow 2 host bits, right? Which will yield a subnet mask going from 255.255.0 now 255.255.192. And now that we've borrowed these two host bits, we have a /18 network, because remember, it was 16, 8 plus 8 is 16. Now it's 8, 8, 2, 18. Now we have a /18. And this picture here shows you uh, the four possible network address or the network address spaces that you can use for your various departments at the office. I know I'm cruising here. We got to keep going. So bear with me. So now we're gonna move on to MAC addressing and ARP. MAC addresses. Those identify the actual physical network card in your device. All right. Yeah, more for organization and for shrinking networks. All right. So media access control addresses. Those again, you have a physical network card in your phone or what your computer, printer, whatever. Those network interface cards all have a MAC address to physically identify them. Yes, they can be spoofed. All right. Before anybody wants to be a wise guy, yes, they can be spoofed. But you have MAC addresses are 48 bits long, 6 bytes long, in other words, and they're comprised. This is the diagram, basically visualization of a MAC address here. So we'll see we have 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, and these are broken up into segments of 3. The first 3 octets, the first 3 bytes, this is the organizationally unique identifier. This is going to say who made your NIC or your device, who made your network interface card. Could be Intel, could be HP, who have you. But this part here, if you look up your MAC address and you go Google it, you say, and there are plenty of sites out there that will, you Google for MAC address lookup, like you paste your MAC address in there, and they're going to be able to tell you who made your NIC based off of this OUI. And the rest of the 3 octets, those are all your that's unique to your NIC. So these 3 octets here are going to identify your actual NIC. So hopefully clarified that up. Moving on, we're going to talk very briefly about the broadcast domain versus collision domain. So I briefly talked about your local area network before. Let's say your device, you're on 192.168.1.0/255. Let's say you're rather /24, my bad, 192.168.1.0/24. And your IP address is 192.168.16, and another device on your network is at 192.168.1.18. Those 2 devices are on the same broadcast domain. What does that mean? That means if PC0 sends a broadcast to a layer 2 broadcast out on the wire, everybody plugged into this, we're just going to assume we're all on the same local area network. Everybody here is on the same broadcast domain, because what's going to happen is PC0 sends up broadcast up on the wire. This switch then floods that broadcast out on all ports, even down the trunk, over to this other switch. So everybody gets the broadcast. That is the broadcast domain. We are all on the same local area network, so when a broadcast goes out, that's the broadcast domain. The collision domain here, in other words, is this shared medium. We have duplex traffic flowing across this single trunk that has the possibility for a collision. With different VLANs, no, because the switch is going to make sure that doesn't happen. So we're gonna talk about VLANs. Sit tight for me, okay? Yes, that's that. Well, the switch is flooding the broadcast. That's what switches do. They'll take a broadcast and flood it out on all ports. It's different than like a broadcast flood or broadcast storm. That's a different thing entirely. But Um, the switch sees that broadcast come up on the wire, and then the switch just says, "Oh, it's a broadcast." Everyone on the same. We're not talking VLANs yet, but everyone on the same LAN gets it. So, address resolution protocol. So the IP addressing is the primary way we identify hosts. Like I was talking before, you're 192.168.1.16. The other guy is 192.168.1.18. Those IP addresses are just easier to remember than MAC addresses. That's why we just use IP when we're talking when we identify devices. Oh, which device are you trying to ping? I'm pinging, X, and that's a bad example, but because ping is layer 3 anyway. But which device are you trying to communicate with? And you use IP addresses to talk about the device. You don't use the MAC address to talk about the device. We just identify devices in host names and IPs. It's just easier to remember. But when you're sending data between two hosts, you need two things. You need an IP address and a MAC. It's not one way or the other. You need to have both of those, because if you look at an IP frame, or if you look at an Ethernet frame, excuse me, you have the Ethernet address, source, and destination, but also encapsulated in there, you have the source IP and destination IP. Because here's the thing that tripped me up for a little while too, is that when we abstract things with the OSI model, we often say, well, MAC address is used to communicate at layer 2 and IP is used to communicate at layer 3, which is true, but it conveys this notion that computers can send data using just strictly the MAC address. Oh, well, MAC's layer 2, so how do I send data using just a MAC? Like, oh, because if it just sounds that way when we talk in those abstractions. Like, oh, I can MAC addresses for layer 2. Kind of makes you think, well, how do I send data using just a MAC? Well, you can't. That's not how it works. A packet, a fully assembled packet, Ethernet frame, that is a specific number of bytes, and you can't remove one from the other. You have to encapsulate down the layers. So you need both a MAC and an IP to communicate. We just use abstractions to say that layer 2 is MAC and layer 3 is IP, but that doesn't mean you can communicate using just one or the other. You have to have both. This is my IP networking flowchart. Just if you want to reference it later, this just kind of shows you how, like, in a hypothetical situation, if computer A wants to send computer B something, this is the step-by-step procedure it goes through. I'm not going to go through now. We're already running a little behind here, so we'll talk about VLANs very quickly. I'll show you my little networking diagram here again. This with VLANs, this is all done. It's a layer. VLANs are a layer 2 concept, and it's all done on the switch, unless you have a layer 3 switch. But I don't want to get too deep in the weeds right now. I'm just going to read from the diagram here that you are the network administrator. You need to log into this switch here and configure the 802.1q VLAN ID on each port. That is a VLAN. So you can see the color coding here, that if, to answer that person's question from before, that if this computer right here sends a broadcast up, who's going to get it? This computer and this computer, because that's the switch's job to make sure that these guys don't get that broadcast. Likewise for these two VLANs, and so on and so forth. But you, as the network administrator, you log into this switch here, and you say, this port is on this VLAN, this port is on this VLAN, et cetera, and then you plug your computers in there, and they all get IP addresses from the DHCP server up here. But it's a two-part equation, because even you've configured VLANs here, but a switch is not a router. So this router up here also needs to know the exact same VLAN tags, so that if this computer tries to send a packet to this computer, it's going to follow. And I cover it in pretty good detail down here. We're running short on time, but essentially it's a two-part equation. if you're moving data between two like VLANs, the switch can take care of it. If you're moving data between two different VLANs, you need a router, and the router also needs to know those VLAN IDs so that it can make sure that they get to the right places. I wish I could go into more detail, but I'll link everybody this slide this info later, and you're welcome to parse through it. We're moving on to OSI model visualization. Again, not going to spend a whole lot of time here, but we're going to talk about OSI in that just need to know essentially two things that are important for OSI is that when the sender sends from layer 7 down to layer 1, the recipient receives from layer 1 up to layer 7. Either one of these could be the sender or the recipient. In this particular diagram, we have a user computer that we're just going to use this example. See if I can zoom in on a little bit. We have these 7 layers: application, presentation, session, transport, network, data, physical. You can see the arrow here indicating the data flow. This is encapsulation. The user enters https sumsite.com. Then what happens is the application data is decoded down to machine language. We start a TLS session over TCP. We finish the handshake. We send the data over 443. Stamp it with the destination IPs. Stamp it with the destination MAC, and then send the bits on the wire down to the switch, down to the router. It gets wrapped up in additional routing protocols, goes over the web, and eventually reaches this server here that's running sumsite.com, and it decapsulates it in reverse. So we take those pulses back from electrical signals and parse the MAC address, parse the IP. Am I the recipient? Yes, yes. We see that okay, it was sent to my my TCP address, my TCP port. We made a good TLS handshake. So yeah, our cryptographic stuff looks good. We're taking that machine code, reassembling it back to encoding it with UTF-8 or whatever, and then we're reassembling back to application. And it sounds slow when we're talking about it, but this all happens at just in a matter of milliseconds. So I also have on this page here, pardon me, I have some neat visualizations about what it kind of looks like when different protocols are encapsulated at different layers. It's color coded, so this hot pink here is, or whatever you want to call it, salmon pink is layer 2, layer 3, etc., etc. And a list of well-known TCP and UDP ports that you should definitely be familiar with, but you don't have to memorize, but just have something like this on standby that you can reference. You want to have that, because you'll never remember them all. But you'll remember the core ones. The key ones you'll remember, but there'll be gotchas that'll come back and you'll be like, oh, what was that port again? And you'll just want to have something like this on standby that you can go look and make sure that you know what it is. Yeah, you'll definitely be asked interviews. Okay, so we touched on VLANs. We touched on encapsulation, decapsulation. All right. So we're moving past the networking section into the programming section. I know I'm probably running a little behind here, so bear with me. I appreciate everybody's time and attention, and I know I'm moving lightning fast. Got a lot to go through here, so
take your time if you need to, because it's a recorded. If people have to go, they can always watch it later.
Yep. Okay. Cool. Yep. I appreciate everybody hanging out. So moving into the programming section, we're going to kick it off with compiled versus interpreted languages. Example interpreted languages, scripting languages would be Bash, JavaScript, PowerShell, Python, and Ruby. Those are just examples. There's a lot more than that, but those are just some core examples. Example compiled languages would be C, C++, C Sharp, Go, Java, Rust. And the example being, I have a great video here that you can watch later that'll describe this in more depth, but just one being with an interpreted language, it's you're not waiting for a compiler and a debugger. You're just pressing run and the REPL. We'll talk about REPL in just a second. We'll run the code. But so REPL, which stands for read, evaluate, print, loop. If you're a beginner to computer programming, starting with a programming language with a REPL, which would be one of these, can be highly beneficial as you can run and change your code on the fly without waiting for a compiler debugger. You get instant feedback on your input. Like if you look at these two examples here, on the left, I have a PowerShell session open where I assign a variable and then I run a command and I get instant feedback. And I can do the same with my Python shell. I can instantiate a variable in Python and then run a print command with that variable. But you can see I can run this in real time. I can run. Thank you, Michael. I can run I can run that Python command right there in real time and get instant results, such that if I was doing a compiled language, I'd have to write my code. I'd have to. I'll answer that in just a second. I'd have to write my code. I'd have to compile it and see what the outputs are. Uh, Whereas it's just instant here. That kind of instant feedback is really important and is honestly one of I credit that for my early exploration in my early foray into computer programming was through PowerShell and just running taking a script, picking it apart one line at a time, putting it in my uh with my PowerShell terminal and just seeing what happens. Just again, picking it apart one at a time. That's the kind of instant feedback that's going to help you. Uh, Not saying to don't start with compiled languages, they're fine. But again, just note that you're going to have to write, compile, and then debug. Whereas here, the REPL is going to give you instant error output. So if you fudge it up, it's going to tell you right there. You don't have to wait for the compiler to check it or anything like that. It's very instant. So REPL is good for beginners. That's why you'll often hear people say start with Python or Ruby or not JavaScript. Sorry, everybody. I'm not sure if we have any JavaScript fanboys out there, but it's a little bit of a beast, but it's it's a joke though. Yeah, Go is compiled, which is fine. And to answer your question, you certainly can come back to a compiled language later. Not saying don't. Yeah, sure, why not? The more languages you get familiar with, the better. Um, so now we're going to talk about data types, primitive data types in computer programming. So there's the primitive data types to be familiar with are byte, integer, basically signed integers, unsigned integers, short, long, floating point, doubles, Boolean char strings. If that all sounds absolutely weird to you because you're not really familiar with it, that's fine. Just know that when we're dealing with byte in programming, we're dealing with raw data, 8 bits of data, raw data. We're dealing signed integers, any negative integer, unsigned, any non-negative integer, including zero. We have a short integer, which is a signed or unsigned integer but the difference being that a short integer gets more memory space than a regular integer. And again, a long integer gets even more memory space than a short integer. So you use these data types based on the kind of data that you're working with. If, let's say, for example, you're taking input from a user and you want to ask the user their age, well, somebody is not going to generally live past 100 and 100 odd. Like that's probably the tops for a person, right? You know, so what do you think would be a good numeric data type to take from the user here? Surely a long wouldn't be good because that's way too massive a number. That's too much memory allocation for such a small number. We could actually assign an age variable to a byte because a byte has a maximum value of 256. if you're following my gist. So it's good to know these data types because you want to make sure you're not abusing not abusing, but you want to make sure you're not uh over allocating memory more than that's needed, because then you're going to be you run your program, you're going to quickly run out of memory space. So you want to be lean with your memory allocation. um uh we have These are all generally integer. Floating point and double are all decimal dotted values. Boolean, we have 1 or 0, on or off, true or false. Char is a single character, and a string is basically a sequence of characters. I'll show you that in a little bit. And we're going to talk about loosely and strongly typed languages. Loosely typed languages such as PowerShell and Python are called so because when you're writing your program, you don't need you don't. I want to repeat that you don't need to specify these data types here. You don't need to. You can, especially in PowerShell, because PowerShell's tight integration with .NET. Less so, you can still get to some degree of tight typing with Python. Bash is no, no, we don't. Is pretty, yeah. Bash is pretty. There's no control over that whatsoever. So with PowerShell and Python, you can get pretty granular with the type of data you want to control. If you as the programmer want to have very strict control over the data type you're accepting or controlling or verifying, you can do that. But it's loosely typed because you don't have to. Strongly typed, such as C Sharp, C++, Rust, TypeScript, when you're writing your programs in a strongly typed language, you have to upfront explicitly say that I know that this particular variable or this function, we're dealing with this particular data. You have to say it up front. That's the whole, just a strongly typed. Loosely typed languages such as PowerShell and Python, they'll make a best effort to interpret the type of data you're dealing with. And I'll show you that a little bit later. Now let's talk briefly about variables and user input. So let's take a brief detour and show you some snippets below. That variables are used to define values or store user input. The values are then archived at a specific address in memory, RAM, and then when the variable's name is referenced, the value is retrieved from memory. You'll often hear variables compared to buckets. You put a value in the bucket and you take it back out when you need it. I prefer to just call variables for what they really are. They're just placeholders. We'll use a restaurant menu as an example. You look at a restaurant menu, you have number 1, 2, and 3. So customers can order from the menu, choosing just the corresponding number. I'd like a number 1. The waitress or waiter is going to know exactly what you've ordered if you say, I'd like a number 1. And even if the restaurant changes number 1 to something different, pulled pork, mac and cheese, and drink, you can still go back the next day and say, I'd like a number 1, and they'll know what you're asking for. And it's the same thing with variables. You put something in the variable, you ask the program for the variable, it's going to bring the data back out. So let's take a look at some variables here. Variables in PowerShell. I have 2 examples. I have Python and PowerShell cover here in my notes for people maybe exploring both. But we have this variable here called first name, and we are storing the value Ben in first name. And if here we're taking user input. We're saying hello, first name, enter your favorite food. And let me see if I wish I could share my screen with you, but you're welcome to try this later in your own PowerShell window or Python script. But I don't want to break away from the screen share here. It's gonna be kind of annoying to flip flop back and forth between both. But if I run this command, read host, hello, first name, enter your favorite food, What's going to happen with this? This is going to translate to Ben. Uh, so when you reference the placeholder or the number one, the computer, the program knows where in memory that's stored, and so we're gonna replace this with whatever's stored here. And right now, Ben is stored here. Likewise, if we change first name to Dan and we run this command again, now what's it going to say? It's going to say, hello, Dan, enter your favorite food. Likewise here, right host, favorite food equals favorite food. Well, that's going to print out whatever the user put in it. For the sake of example, it's because I feel like I'm shortchanging you guys if I don't show you. Let me share my screen, and we'll run just quick example of that code. Okay, can everybody see my PowerShell window?
Got it.
Cool. Let's do it. So this just finished and ran, right? First name, we stored Ben. Now we're moving on to the next line. Favorite food. Read host, prompt, hello, first name, enter your favorite. So here we go. Hello, Ben. Because this translated, this retrieved that value from memory. Enter your favorite food. I'm gonna say, let's say pizza, whatever. And then finally we have, thank you, Ben. Please also tell me your favorite pastime activity. We'll say hacking, right? And then we'll run this last bit of code here. Right host user, first name is Ben, favorite food, pizza, favorite pastime, activity, hacking. All right, makes sense. So same thing in this is the exact same code in Python, the exact same code. It's going to do the exact same thing. So if you want to go and practice that later in a Python script, go for it. Data types and actions. So let's take a look at some data types. We've got, we're again using variables to store these data types. This is an integer, 10, float, 10.1, a short integer, 1, 2, 3, 4, 5, 6, a long integer, much longer, need much more memory, a Boolean, false, string, hello world, string 2, 100, wrapped in quotes. When 100 is wrapped in quotes, it's not an integer, it's a string. We have to specify char here because we're dealing with a single character. We can also request an integer from the user. We can again kind of going back to that point with when we want to strongly typecast. I'll show you one more time just for a sake of example. Wish there was a better way to share multiple screens, but for this example here, you'll see we have this int right next to this variable name. What we're saying here is that when we take input from the user, if we're saying that whatever value gets stored in here must be an integer. That's what when we were talking about those loosely or strongly typed languages. This is where we as the programmer are now using a strongly typed language. Because we're predefining the kind of data that we expect the user to pass in. So let's see what happens if I pass a letter A. It says here, cannot convert value A to system int32. Input was not in the correct format. I do not always use I don't do that unless I really want to be explicit. I generally don't define the type that I'm expected to deal with. Now, if we pass in a 100 and we concatenate the value. Everybody's happy. So again, it's up to you as the programmer whether or not you want to be strongly or loosely typed. There just may be instances where, like, yeah, this needs to be a specific data type. Then yeah, then definitely do use strongly typed variables. We're going to talk about string interpolation here. Um, this I think this comes from that lesson in the TCM Academy where we have advanced strings. So what we're doing here is string interpolation. So showing from going back to that point before where we're storing in name Ben and drink coffee, and then if we run this command, this is going to write out into our PowerShell screen, hello, my name is Ben and I like coffee. That's string interpolation. You have these variable names being translated into the string here. Likewise here, this is a format where PowerShell has this F operator. This is another way to format the string. So these are numeric placeholders. 0 is the first and 1 is the second. So these are comma separated. This is your first, this is the second. So this one's going to go, this is going to go in 0, and this is going to go in 1. And this is the exact same code in Python, just Python has a slightly different way of doing it with your F format right here. But again, same thing where what we're doing is we're saying store Ben in name and coffee and drink, and then substitute them out so that my string says, hello, my name is Ben and I like coffee. Doing the same thing here. Hello, my name is Ben and I like coffee, where we're substituting the S placeholders and then here the curly bracket placeholders. Just 3 different, basically, the result is the same, the method is different. It's just looking at the operators here. We have arithmetic operators, relational operators. Gonna kind of breeze through these, but basically what we're doing is we're looking at to see if things are equal or not equal. We're doing arithmetic. I'm gonna like I said, I'm gonna probably breeze through a little more of these because we got probably to move on a little more. But I'd encourage you to go back through here and look at our arithmetic operators to see how you can do arithmetic in Python and PowerShell, and also compare strings and numbers so that you can see Python is going to return 20, 15. Here, 1 is equal to 1. Python's going to return true. 2 equals 1 is going to return false because it is false. String equals string is going to return true because this case sensitive comparison. This is going to return false because Python is case sensitive. 3 does not equal to 2 returns true. 3 not equal to 3 returns false because 3 is equal to 3. Saying 3 not equals 3 is false because that's a false statement. These are arithmetic operators, and we'll use those in conditional logic later. Here, we're looking at collections, lists, and arrays. With PowerShell, what lists and arrays are essentially, we use collections to assemble 2 or more things together. Some collections allow you to commingle data of varying types. Some collections are immutable, meaning that once created, they can't be modified. For example, your program may want to allow user to only select a list of permitted items, like maybe country codes, or maybe it's a menu where you only want a specific amount of things to be available. In PowerShell, we're looking at fixed length arrays. These are all the ways to instantiate arrays. So if you want to have a single item array, this array is only going to have 1 cat. This is only going to have 1 dog. This array is going to have an A character, a 1, the string 2, the string 3, and the byte A. This is going to be the exact same array, just a different way to instantiate it. And here, if you run this code in your PowerShell session, it's going to tell you the count, how many things are in each array. So this one will say 0. This will print out the items in the array. So if everybody's still hanging with me, I'm going to give you a quick example. We'll look at those arrays really quick. So let's run these. Let's run this little bit of code here. And we'll take a look. So here's this bit right here. Where I have instantiated the arrays, and here we're gonna look at these specific arrays. So empty array.count is equal to 0 because it's true. We have nothing in that array. Single item array, we're printing the array, and that has just one cat, which is true because that's what I put in it. Single item array 2 has dog because that's true. That's the only thing I put in it. New array 1 has A, 1, 2, 3, and byte 65 because that's what I put in it. And new array 2 also has the exact same thing because that's what I put in it. And there's 5 items in that array. So if we look at new array 2 one more time, you can see essentially the key takeaway from this lesson here is an array is a list of things. It's 2 or more things, technically 1 or more things in a list of items. That's the key takeaway here. So when you hear somebody talking about arrays or lists, we're talking about 1 or more things stored in basically a list of things stored together. Now, if I took new array 2 and tried to add, let's say coffee to it, we're going to say this collection was of a fixed size. You're not allowed to add anything to it. There's two ways to work around that. We can do new array 2 plus equals coffee, or we can create a basically an array list. Not to bog you all down here, but there are different array types. Again, the behavior of arrays varies from array type to array type. An array list is not a fixed size. So we can say new array 3, and new array 3, because it's an array list right here, we can add an item to it, and it's not going to complain because this is not a fixed size list. I'll show you that back here in the lesson right here, this portion on line 37 and down. This is a variable length array. This array type is going to allow you to add or remove items freely. Immutable arrays are similar to Python tuples. Once the array is created, you can't add or remove anything to it. So if you try to run this code right here, it's going to throw an error. You can't change anything about the array. The array is immutable. And a hash set is similar to Python sets. Down here, exact same code. The whole reason for a set is that an item will only exist once. So if you try to add cat twice, down here or up here, whether it's Python or PowerShell, cat will only ever exist once in the array or in the list. Thanks for joining. Appreciate you coming out, and I hope you have a good night. Dictionaries and hash tables are actually another type of collection. This is a collection of key value pairs. So that when you create this hash table or this dictionary, you're saying that this key, AU, the AU key equals Australia, the CL key equals Chile, the JP key equals Japan, and so on and so forth. So that when you call the US key or the KR key or the JP key or whatever, you're retrieving the value on the right hand side. Um, yeah, I'm sorry, guys. I know I'm running long, but I appreciate you coming out. Um, Moving on, we have the program flow control logic. So we have if else logic. Basically, we're saying we'll start a variable age 20. If age is less than or equal to 20, run this code. Else if run this code. And basically, the way if else logic works um, is if this is true. So we're going to try this section. We're going to try this statement first. If that's not true, then we'll try this. If that's not true, we'll try this, and then else we'll try this. That's the gist between an if. That's the gist of an if else logic block. Now, with a multiple if logic block, you're going to try your. It's not if else. They're all ifs. So we're going to try them all. So if this is true, do this. Also, if this is true, do this. Also, if this is true, do this. So that's the thing you got to know between if else blocks is they behave differently. Whereas with if else, once the true statement is found, we're going to process it and stop. Whereas with multiple ifs, they're all going to run if the condition is true. I won't cover switch because it's not relevant to the TCM class, but you can come back and look at it, the switch block, if you'd like. We'll talk about loops here. Watch out for infinite loops. An infinite loop is just a condition where something never stops being true. One will always be one. A will always be a. True will always be true. So if you get in if you create a condition that doesn't stop being true, you've created an infinite loop. These are just some examples in PowerShell Python. If you want to go on your own and try to create an infinite loop, you just want to press this Control C key to get out of it. We'll skip that for now. Just running short on time here. The for each loop, what we're doing essentially is it's a little bit of gap there. These two should be pieced together, but what you're doing with a for each and a for loop is that you have a bucket full of animals and you're taking one out at a time and processing it. So if you see for each animal in animals, where animals equals dog, cat, parrot, horse, we're going to say for each animal, write host, say hello to the animal. So what's effectively going to happen is we're going to do this 4 times. We're going to say hello to the dog, say hello to the cat, say hello to the parrot, say hello to the horse. You're just taking them one at a time out of the bucket until the bucket is empty and processing them. For loop, we'll skip it because it's not relevant to the TCM course, but you're welcome to reference it later. A while loop in Python or PowerShell, basically we're saying create a variable called counter that has the value 0, and while the counter variable does not equal 10, we'll write the value of counter and then increase it by 1. I'll show you that real quick here in the terminal. So what we've done here is counter eventually equaled 10, so we stopped. So while counter not equals 10, write the value of this variable, increase it once. So it started at 0, so we wrote 0. and then increased it to 1. And we wrote 1 and then increased it to 2, and so on and so forth. Well, sorry. I think I meant to share I didn't show you that, guys. Sorry about that. I didn't show you guys the actual meat and potatoes there. But yeah, so meant to share it. But so yeah, we started at 0, it incremented until it eventually equaled 10 and stopped. All right. Classes and objects. We're going to breeze this pretty quick. I don't use ISC. I have Visual Studio Code. I probably could use that. You're right, but I don't see the content coming through. Hang on one sec.
Yeah,
I'll
we're
try
not
one more
getting your
time.
screen for some reason.
Is it coming through?
No.
It looks like it's spinning on my end.
It's showing an error. That's weird.
Well, shoot. I think we lost Sean too. I feel like Sean is just sitting still.
You guys see me or no? Can you hear me still? Maybe it's only on Ben's end.
Let's see if I can. And try one more time, and if it doesn't work, well, might be just the cue to wrap it up. But
It looks like I got booted there for a second. I think Ben broke Discord with his material. His material's so good. Well, we'll give him a minute to see if he can get back in. But you guys can still hear me, right? Okay. His brain has a lot of bandwidth. I'll be showing in my
oh,
chat too, guys.
I don't even know what happened there. Can you guys hear me?
I can hear you now. Yes.
It's unfortunate, but
I dropped and then you dropped.
um, I guess we'll try to wrap up here. Appreciate you guys hanging out. So classes. Are you recording in there, Sean?
Oh yes.
Okay, cool. So object-oriented programming, I really don't want to get too deep into it, even though we could, just because I've stolen so much of y'all's time. But and this is a deep subject, but we're just going to do a surface level examination of classes in PowerShell and Python. These are the exact same classes, whether it's Python or PowerShell, whatever you happen to be looking at, whichever code block here, it's going to run the exact same code. But basically, what we're doing here at lines 3 down to 29, we're defining a class called a person. The class is a template so that you'll see here on line 34, when we create a new object using this person class, it's going to inherit all of these properties from the class. So we'll inherit a first name, a last name, an eye color, age, nicknames, an eat method, a walk method, and a sleep method. Those are all going to be inherited from this parent class, such that if you want to give your person new attributes, you just modify the template. So let's say you want to add a shoe size property to your class, then you just here insert a new line below here, and you just insert an integer called shoe size, and then you just rebuild your object, and now your object inherits that new shoe size from this template. So you don't add the shoe size here to the object, you add the shoe size here to the template and rebuild your object and then populate the shoe size. This is your template. You build objects off of your template, off of your class. So you start a class, you define a class, and then you build objects off of the class. So you start the object and then you fill it out. So we give this John Doe object built off the person class. We give it a first name, a last name, an eye color, an age, a nickname, and then shoe size if we decide to add it later. And then we invoke methods. We're going to use the eat method to eat spaghetti. And that method is going to say that spaghetti was. So if you run this method with the word spaghetti, that's going to cause this object to print off that spaghetti was delicious. And then so on. We're going to say if we use the walk method, that's going to print here, I walked 10,000 steps, and sleep is going to pause for 10 seconds. And the same thing is going to happen exactly here with your Python code. So it's just whether you decide to use PowerShell or Python, if you want to add a shoe size, you just go here and you line 9, you bump down a line, you add self.shoesize equals 0, and then you build your class here on line 27. You build your object from the class, and then you fill it out, and then you invoke your methods. Functional programming is so the bottom line of functional programming is good code is dry code. You don't repeat yourself. If you find yourself repeating the same lines of code, it's time to stop and refactor. Why is code that repeats bad? If you update one code block in one section, but you forget to update that exact same code in another spot, you could introduce a bug. So code that is dry is the code that is not dry is difficult to maintain, and conversely, code that is dry is not difficult to maintain. The point is that you write once, reference many. So you write the function and then you use the function where it's needed. I'll give you an example of some non-dry code using both Python and PowerShell, and they're exact same code blocks, whether you reference the Python or PowerShell. So we have an int 1, int 2, 10, and we get the product by multiplying int 1 times int 2. And you can see in this code block here, it's rather contrived because, like, it's a very artificial example of non-dry code. It's not natural. It's not natural code in its natural habitat. It's a contrived example for the sake of this lesson. But nonetheless, we're repeating this process of multiplying numbers 3 times, where we should rather just write a function that takes 2 inputs, multiplies them, and returns them, such that we can call this function anytime henceforth, forever and ever, in our script, anytime we need to get the product of 2 numbers, rather than adding this every time you want to do it for a new set of numbers. You just say, call my function, here are the 2 numbers I need to multiply, give me the output. That's a much, even though it looks like, hey, this looks a lot more complicated than this, like, yeah, okay, it does, but you want to keep, you don't want to keep adding this to your code over and over and over and over again as much as you need it, because it's just not scalable, it's not good, it's not clean, it's not dry. You write once, reference many. This is the exact same code here, where we rather than have this multiple times, we define a function and do the same thing in Python. So, and then finally, we'll talk briefly about creating well-designed functions. Well-designed functions do one thing well. When you write a function, it has one job. Your function is not a massive toolbox. Your function is just one thing. So you create a function to multiply, you create a function to add or whatever. Those are contrived examples, but still, the point being, a function is a tool that should be called repeatedly to do one thing well. It should also be idempotent, and idempotency means that every time the function is called, the function should repeat, should produce consistently the same outputs or the same errors. So every time the function is called, we should expect that the function returns the same kind of output or the same kind of error, uh, depending on what condition was created. Um, and just as a screwdriver was intended, don't get clever here because I know we could technically use a screwdriver as a chisel or whatever. Yeah, you're right. Don't get clever. Okay, the screwdriver was intended with a single purpose, and so too should your functions be created with such a mindset. Final module here, and we'll back up. We're going to talk about, because TCM does talk about modules. We'll talk about modules in PowerShell and Python. And what is a module? Well, if we discussed just briefly before that if a function is a tool that does one task well, a module is an extension of this concept in that modules are collections of classes, collections of functions and other code. And this one module has one specific purpose. So you could take a look at there's a module that we saw briefly in one of the, I think it was in just this last bit of code here. We're importing the time module. This is a default, it's a Python module. It should be available in most default Python installations. This is a module. We're importing the time module. What do you think the time module does? Well, it probably does lots of different things really well pertaining to things that relate to time. So sleep, calculating maybe different time differences between two timestamps or what have you. But it's a time module, so it probably contains lots of different functions and classes, pertaining to, related to things pertaining to time. That's why it's called the time module. It's not called the time and cryptography module or the time and whatever. It's a time module, and there's probably a separate crypto module, and there's probably a separate whatever module. So modules are by extension they're a toolbox for one particular scenario. Your module should not seek to be an all-purpose solution. So because you'll probably at some point be creating modules. You'll write lots of, because I've done that before with PowerShell. I've written lots of functions, and then I think, well, hey, these would all work really well together in a module. And you'll probably do that too. And if you decide to publish your module, that's another thing. But with these specific commands here, what I'm demonstrating to you with these commands is finding and installing modules from trusted internet repositories. When you run the find module command in PowerShell, you're searching for a module in a trusted Microsoft repository. You can add third-party repositories to search for modules from, but by default, in a default PowerShell installation, when you run find module, we're searching a Microsoft PowerShell gallery. Same thing with Python down here. When we use pip, it's install when you browse PyPy here for a specific module, and you go here in Python pip install module XYZ, that's pulling that module from a trusted internet repository. So it's the same thing when you run Python pip install module name. We're saying install a module from a trusted repository. So here, this is an example of piping output. So we say find module name, pipe it to install module, and then we're going to install that PowerShell module to the current user scope. Same thing that actually happens in Python as well. When you run install module with current user scope, we're installing it as our current user so that it's not going to be accessible to other people's PowerShell module paths. Same thing happens with Python on a Linux box or even on a Windows box. But when you run sudo Python pip install, you're installing that as root. You're making that module. Uh, Typically, if I remember correctly, you're putting that in a globally available uh, install path, if you will. And so if you actually, and I'll show you really quickly here. If we look at the really quick, we look at the environment module, PS module path. These are all the folders, and let me split it on semicolon. These are all the folders where PowerShell is going to attempt to import modules from. So if I say import module PS toolbox, which is a module I've written, but apparently not on my system right now. Well, it's saying it can't find that module because it's not, that module doesn't exist in any of these paths here. So but let's change that really quick, right? Let's do documents, Windows. So you need to create that directory. Let me create this directory really quick. You get HTTPS code.com. Oh shoot. Well, you can't. Sorry, guys. I can't do it right now. I don't have Git installed in here. Sorry. Anyway. But if I get cloned it to if I get cloned it to here, then that import would have worked. But anyway, Python also has a similar feature where again, I don't have Python on here as well right now. It's a pretty new laptop. Sorry. But if you run this command in a Python interpreter, so I can SH in my Kali box really quick. Let's see. And we run this, we can see that these are the lookup folders where Python is going to attempt to import a module from. So there's a lot of similarity at play between PowerShell and Python with respect to modules, in that there's a hierarchy, there's a search hierarchy that when Python tries to import a module, it's going to look here. When PowerShell tries to import a module, it's going to look here. So that's what I'm trying to cover in that documentation there. So share that. We'll wrap up. I think we're nearing the end. And final, so we're here. I'm leaving you with some follow-up work. Autodidactic learning time, the best learning time. Like you should be. I realize I have my camera on. Not like it's not important because I'm not that important to look at anyway. But
I think you're handsome.
oh, thank you, sir. Glad one of us thinks so. Yes, it is. It is. The PowerShell module verification is in the notes. Right here. If you print env PS module path, that will tell you where. As you know. So, yeah, let me check real fast. Yeah, right. Oh man. Stop it. You guys are distracting me now. So autodidactic learning time is the best because that's that's the shit, you guys stop, man. That's where you learn on your own. It's driven by you. It's just you explore by yourself. You get your hands dirty in the Python interpreter, the Python shell, the PowerShell. Just take this code that I've shown you today, and play around with it. Play around with it in your shell and see what it does. And then finally, I challenge you to complete these videos from the TCM Academy. Complete the sockets video. Complete the reading and writing files video. The building a port scanner video. And the building a shoe budget tool video. And I've given you supplementary PowerShell code to go with those videos. In that, I'm showing you here how to read and create basically create, write to a file, and read from a file. So TCM is going to show you how to read and write files in Python. I'm showing you how to do it the PowerShell way. So you can reference this later if you'd like to play around with creating a file, writing to it, and reading from it. I'm giving you this code here. And I'm also giving you a supplementary TCP port scanner I wrote in PowerShell. Not the best TCP scanner, probably not the worst either, but if you'd like to play around with this function I wrote to test TCP ports, we can actually just show it real quick. Show you how it works. Let me show you so you can familiarize yourself with it a little bit later. We have my PowerShell session here, and we import my function. All right, function's imported. What's my function name? Test TCP port takes a parameter target host, a port, and a number of threads to use when testing, and the timeout to wait before we determine that the port is closed. Let's do this. We'll say test TCP port. We'll hit tab a couple times on. We'll hit start a dash to define our next parameter. Hit tab. Okay, target host. We'll use my Kali box. Port. We'll do 22. So I know that's open. And then threads. Say 10. And we'll wait 100 milliseconds before we call it. So, and we get back target 1066. State is open. Now let's try a port that I know is going to be closed. We'll do 422, and there we go, closed. Not the best, not the worst, but just a supplementary bit of code for you to accompany you with the TCM code that you'll probably encounter when you're doing the building a port scanner video. So in case you're curious, like how do I do this in PowerShell? There you go. Now, is it smart to write it in Python if I'm familiar with that? Yeah, definitely. And I very much agree with that statement. You definitely take full advantage of ChatGPT for your code conversions. I wouldn't say it's foolproof, but it's gonna
It's
it's gonna
definitely
at
not.
least gonna get you. It'll get you a good framework. At least, yeah. If you have in Python, you're like, hey, how do I do this in PowerShell? It'll get you a good bit of the way there, at least to give you ideas of how to take it from proof of concept and beyond. But yeah, ChatGPT can be a great resource when doing code conversions between different languages. But yeah, we've reached the end of the lesson. Let me link you guys to the thank you so much. I really appreciate the kind words there. This is the link to the session. Um, thank you. I mean, I appreciate you I appreciate you showing up. I appreciate the kind words. Um, yeah, I mean, I'm happy to do it. Wow. Go to sleep, dude. No, but thank you for coming. Thank you for coming over and checking it out. I really appreciate it. Thank you. Yeah, thanks for coming and checking it out. I appreciate it.
Those two screenshots I just shared are what I'm working on for next week. It's separated because we're leaving video one, the free video one on YouTube next week, and we're moving into the second video. So if anybody was curious.
Any other questions? I mean, I'm here to answer questions for probably another 5 minutes. I gotta got a kid we gotta get to bed, but happy to hang out for a few more minutes and answer questions.
Did you get the OOP one
Please.
already?
Let's see. Sorry for the late ask. Would you be able to name some cities? Yeah, I mean, well, so I'll take the low hanging question there real quick. But Markdown, yes, it does have Markdown. This is it's a platform called Bookstack. So if you can look it up later if you'd like. Uh,
Now,
now, in
coffee, he can
terms of
answer.
yeah, that yeah. In terms of the OOP outside software dev, well, the thing is with OOP, OOP exists to take complex problems and break them down into smaller solutions. And that's really what computer programming and the concept of abstraction is all about, is that you take difficult multifaceted problems and you break them down into smaller problems and smaller problems until you can basically make them bite-sized chunks and have the problem become much more approachable. And that's essentially what OOP tries to do. So OOP outside of software dev, um, yeah, basically, yeah, encapsulating data and problems and things to try to make them more understandable. So to take OOP outside of software dev would just involve taking complex problems and breaking them down into smaller parts and categorizing the parts of the problem into data. Yeah, yeah, absolutely. You don't want monolithic programs. That's what functional programming is all about. So if you look at my PowerShell modules, you'll see that all my modules are comprised of lots of individual files, and each file represents a single function, such that it's not monolithic. And if I need to update something, I update one file. So yeah, you don't want a monolithic program. You want to break things up into smaller functions, into smaller bits.
Anybody else?
Oh, you know what? That's a valid question. That's a valid point, Birdie. Yeah.
I
So
actually
it's
do have the chat showing on the YouTube video though.
oh nice. Okay. Good call there, Sean. Okay, thank
But
you.
good call for next time. I'm new to this.
Yeah. Yeah, I appreciate you pointing that out, Birdie. Yeah. Uh didn't really think about that. You
Anybody
should
else
probably go to
going
sleep.
once? Big man got to go eat dinner. All right, I guess we'll wrap up. I'm sure I speak for
Cool.
everyone. That was more than enough that you prepared.
Cool. Happy to do it. Yeah, I mean, I appreciate everybody showing up. Thank you very much.
All right. I hope I see some of y'all next week. Later, guys.